This video is about composite transformations, but specifically talking about the domain and range of composite transformations. First example says, if the domain of a function that is reflected over the x-axis is 3, 4, 2, negative 1, 1, negative 1, 2, what is the range? When it says if the domain is really the pre-image coordinates. So this all it's saying is the pre-image coordinates. So we have the pre-image coordinates. It's asking what is the range. The range are just the image coordinates. So when we find this, we're just given the pre-image, and we want to use the rule to find our image. The function is reflected over the x-axis is 3, 4, 2, negative 1, and negative 1, 2. So that's our pre-image coordinates. The rule reflected over the x-axis is x, y, maps to, since this is over the x-axis, we're going to negate the y, so x, negative y. So when we find this, we find our range, because it's just asking for our range, which are the image coordinates. It's not labeled as A, B, or C, so we don't have to put A, B, or C, or A prime, B prime, C prime. Our range tells us that it is our primes. So we just want to negate the y values. So we have, the first one is 3, negative 4. Then we'll have 2, positive 1. And then we'll have negative 1, negative 2. Those are our range coordinates, so that's our range. The next two examples actually go back to writing a single transformation rule and how it goes into effect of if you have the single transformation rule, how did you really get it? So this next example is saying if you're given the domain, and then this example says you're given the range. So if you're given the domain, you do it one way. If you're given the range, you do it the exact opposite. If you're given the domain, you're actually given you plug letter in, and you get the location of your image. The location. So that might be the front or the back. So that could be the front or the back. It depends on what you have. If you're given the range, you actually plug it into the location. Plug into location, and you get the letter. You get the X or the Y. And then once your X always comes first, your Y always comes second. That's if you're getting the letter. So you're getting your domain, which means your X and your Y. But if you're given the domain, you plug your X in for your X, wherever it's located, and you get that location. So if you plug it into the front of the problem, you get the front of the answer. If you plug it into the back of the problem, you get the back of your answer. So in this case, we're given the domain. If the domain of the coordinate transformation, we have f of x, y. So this goes back to that function notation, domain and range. This is almost very similar to that mapping rule. So this is x, y maps to, and then this is our transformation that it's asking us to do. Now there are multiple transformations happening here because it's not just one thing, because the y's and x's aren't in the correct location, and you also have numbers added and subtracted. So there is more transformations. It's a composite. So it's actually asking what transformation or transformations has occurred. So the first thing we need to do is, we know there's going to be multiple transformations. We need to find the range. So to find our range, we actually plug the letter in to get the location. So this first coordinate is a 1. It's an x value. So we plug that 1 into the x value of our rule. Now the x value just happens to be back here, which is perfectly fine. That just tells us that our location will be in the back. So when we have this, we'll have our parentheses, and then our comma, and we'll find out what our range is. So let's look at the first location. This location is in the front location, but we want the y number. So the y number of our first coordinate is a 4. So this is really 4 plus 1. And then in the back location is where we put in the x. So this is a negative times a 1 and then minus 4, because it's the x coordinate, it's the x number. So we have negative 1 minus 4. And we're going to do the same thing for these next two coordinates as well. So we're going to go ahead and put these in. So the next one we have in our first part, our first location, we actually have the letter y. That means we're going to use this letter y, the 2. So we're going to put the 2 plus 1. And then in the back location, we have the letter x, which is a negative 3. So it's really a negative times a negative 3, then minus the 4. And then for our last coordinate, again, we take that front location, which gives us is really the y. So we want the y value of our coordinate, which is this negative 1. We're going to add 1 to it. So negative 1 plus 1. And in the back location, we actually want to use the letter x. So we use this negative 1. So we have a negative times negative 1. And then minus 4. And then this actually gives us our range. So our range, our coordinates will be 4 plus 1 is 5, comma, negative 1 minus 4 is negative 5. Then we have 2 plus 1 is 3, comma. Negative times negative 3 is a positive 3, so it's 3 minus 4, which is negative 1. Then we have negative 1 plus 1 is 0. And then it's a negative times negative 1, which that is a positive 1. So it's really positive 1 minus 4, which is a negative 3. So this is our range. We have our range, but it's also asking what transformation or transformations has occurred. And hopefully we've already noticed that because there's multiple things happening to here, not just x and y, that it will be a composite. So there's going to be multiple ones. So if we focus on our x's and our y's right at first, just the letters, you can see that the x and y is actually flipped, but then only the x value is negated. So if you flip the x and y, it's either going to be a reflection or a rotation, but if you only negate the back number, that's going to be a rotation of 270 degrees counterclockwise. So you actually you rotate 270 degrees counterclockwise. And then, because we focus on the y's and the x's, now we look at the plus 1 and minus 4. Now the plus 1, again, since it's in the location, the front location, this is on the horizontal. So this is really adding 1 to the x's. So that's really a right 1. We're actually going right 1 because it's in the location. It's really based on the location. Then, because we have a minus 4 in this location, in the back location, that's the up and down, it's really going down 4. So again, you plug in your actual letter, so you have x and y, xy, xy, wherever you see the x's and y's, and you get the location of the image, so of the range. So this is the location, even though you plugged in the y number, you got the x location of our range. For that next example, we're actually given the range, so we're actually given this information, and we have to go back and find the domain. So this time we actually plug in our location. What that means is that our location, our x value of 10 is the location of the front, so it's still the front. So that 10 is actually replacing this. That if it's replacing, that means that is actually equal to it. So for our x's, our x coordinate right here is the same location. What that means is that you can set this first location, that 10, equal to the front location. So we have that 10 is equal to that negative 2x. Then you can take that negative 2. If it's in the back location, it's the same as the back location. So we can set that negative 2 equal to that back location. I do want to make sure I keep these together because this was my range. So I have to get my domain from using this information and the rule to get to my domain that will end up giving me this range. So I just have to keep them together. So I have my negative 2 is my back location. So I have my negative 2 is equal to my back location, which is negative 3y plus 1. We can then go to the next coordinate. We'll have our front location, our 8, is equal to our front location, which is negative 2x. This is what I was talking about, plug it into the location. You have your location, plug it into the location, not to the letter. You're not plugging anything into the letter because you're trying to get the letter out of it. You're trying to solve for that letter. So then again, with the 8, we have the negative 5 in the back. So we have negative 5 is equal to the back location, which is negative 3y plus 1. And then our third coordinate, your front location is negative 2, equals the front location of negative 2x. Then the back location, 4, is equal to the back location of negative 3y plus 1. So all of these are the front locations, so they're equal to the same thing. All of these numbers are the back location, and they're equal to the same thing. So now we just solve for each individual one. So 10 equals negative 2x, divide by negative 2. 10 divided by negative 2 is negative 5. 8 divided by negative 2 is negative 4. And negative 2 divided by negative 2 is a positive 1, so x equals a positive 1. We have all of our x values. Now to find all of our y values. So we want to subtract the 1 to get negative 3, and then divide by negative 3. That's equal to a positive 1. Subtract the 1, you get a negative 6. Divide it by that negative 3, you get a positive 2. Then you subtract the 1, you get a 3. Divided by negative 3 is a negative 1. So now what we do is we write out our domain. Our domain is your pre-image coordinates, and you get the letters. So what that means is your letter of the x and y coordinate. So whenever you have the letter, you actually put it where the x and y coordinate truly goes. So this first part right here, we have x equals negative 5 and y equals 1. These have to stay together because they came from the same range, so they have to go together with their domain. So the x is negative 5, and that's always in the beginning of our coordinate, and then our y is 1. Then we have a negative 4 and a positive 2, and we have a 1 and a negative 1. So if we could actually do what we did up here by plugging in our domain into the function and getting out the location, and we'll get this range back. So we could do the same thing for here. For up this example up here, we could actually set the 5, because it's the location, 5 equal to this, and we'll get our letter out. So 5 minus 1 would give us 4, which is actually our letter of y for that first one. So these are opposites of each other. You do the inverses of each other. This last example is you're using the graph below, and if this transformation was written as a function, as this rule, identify the domain and range. So the domain is always your pre-image coordinates, so it's the ones without the primes on it. So we have an A, B, and C. We just want to write out our coordinates. Now we do want to just go in order. If you go in order of A, B, C, make sure your range also goes in order of A, B, and C. So our domain is our A is at negative 3, 1. And since I'm just finding the domain, I don't actually have to label it as A because I'm just finding the coordinates. I do want to make sure I do go in order, like I said, of if I go A, then B, then C, I need to make sure my range does the same thing so that domain goes with your range. So the next coordinate was at B, which is at negative 2, 3. And then C is at 1, positive 2. That's your domain of our function. It's written as a function. So then our range is our image coordinates, which are our prime. So if you see A prime, B prime, C prime, you write out those coordinates. Now again, we want to go A, then B, then C. So A prime is actually at negative 5, negative 3. B prime is going to be at negative 3, 1. And then C prime is at 5, negative 1. And that's how you just find your domain and range, your pre-image coordinates and your image coordinates, and you have your domain and range.